Good afternoon, everyone. Thanks for joining the session today. My name is Neeraja Rentachintala. I lead the product management for Amazon Redshift. I have two co-presenters with me, Shruti Warlikar. She is the senior manager for analytics specialist SA team at AWS. And Shyam Mahapatra, he is the director for Johnson North America Commercial Data and Insights Group at Johnson & Johnson. Today, we are very excited to talk to you about how AWS and Amazon Redshift can help modernize your data warehouse environments. Before I go deep dive in, can I get a quick show of hands on how many of you actually already use Redshift today? Okay, and how many of you are using some on-premises system, database, data warehouse, and looking to migrate to cloud? Nice, we have a good mix here. So this is our agenda today. First, I will start with what are some of the motivations for considering data warehouse modernization. And then I will talk about some of the key tenets and the use cases of a modern data warehouse. And then I will go a little bit deep into the capabilities of Amazon Redshift for enabling this modernization. Then Shruti will do a demo, followed by Shyam sharing with us their data warehouse modernization journey at J&J. Data in organizations is growing exponentially. We see that customers want to derive insights from all their data and make it available for all their users in the organizations. Traditional systems are complex, rigid, and do not scale for the growing data and analytics demands. And we see that customers struggle with performance at scale, rising costs, and just most importantly, unable to get to the data faster. So these are some of the common reasons we hear from customers on why they want to consider modernizing a data warehouse. At AWS, we believe that a data warehouse is not a silo. A modern data warehouse should do everything that a traditional data warehouse did, which is supporting your business intelligence analytics needs with high performance, but it should do more. It should enable you to scale to petabytes of data and make the analytics available to thousands of users in the organization, including the users that don't have database management experience, enabling them with self-service capabilities. In addition, a modern data warehouse should open up new use cases. For example, being able to run machine learning directly on top of data warehouse data, and enabling you to do analytics on top of all data sources, such as data lake, operational databases, streaming data. And once you have access to all this data, share it consistently throughout the organization. And another emerging use case we hear from customers is third-party collaboration, which is from your data warehouse, you want to be able to consume third-party data sets and join it with your data in the data warehouse, and also take the data in your data warehouse and make it available as a service to your customers, your partners, and the business ecosystem. So third-party collaboration is another very common use case. With Amazon Redshift, we have been closely listening to our customers, anticipating the changing landscape demands, and also looking at our fleet to understand what is working, what is not working. We have been reinventing data warehouse for the past 10 years, since Redshift is launched in 2012 as the very first cloud data warehouse. I'll cover some of the key capabilities in subsequent slides, but our ability to query the data lake directly, ability to query operational databases directly, in-database machine learning, concurrency scaling. So all these capabilities are enabling tens of thousands of customers to derive meaningful and differentiated value from all their data. At the core of Redshift innovation is its superior price performance, which is enabled by a number of capabilities such as distributed data processing, vectorization, materialized views, advanced query optimizations, efficient encodings, a number of performance features which enable Redshift to be 5x better price performance compared to the alternative data warehouse systems. And the price performance of Redshift maintains as you scale with more number of users and more number of queries, and also as your data volumes grow, making the data warehouse costs a lot more predictable. On the left side of this graph here, there is the price performance graph for a high throughput workload. This is many users coming in and querying the data warehouse. So small queries, high concurrency, where throughput is very important. In these scenarios, Redshift offers up to 7x better price performance compared to the alternative systems. The right side graph here is for data. So Redshift allows you to go from gigabytes of data to terabytes of data to petabytes of data seamlessly and maintains the price performance. So now let's dive into some of the capabilities of Redshift as well as its integration with the rest of the ecosystem to enable data warehouse modernization. The first step in data warehouse modernization is actually migration from your on-premises system to Redshift cloud in general. So this is where the capabilities matter, the features matter. So Redshift offers rich ANSI SQL capabilities and also connectivity to the BI and analytics tools. We also offer a simpler application development API called Data API, with which developers can write applications in Python, Node.js, whatever the language of their choice, and build analytic applications very easily. Redshift also supports all data types, including semi-structured data, spatial data support. And at reInvent this week, we launched additional SQL capabilities such as merge, which is in SQL, standard SQL syntax, with which you don't have to delete and add new rows. You can just merge for the fast-changing data type of workloads. And additional functionalities such as OLAP functions, rollups, cubes, grouping sets. But the idea is the Redshift has all the necessary SQL capabilities to make migrations easier. And a very important thing to note is security. So security is critical for the adoption of data warehouses across different use cases and across your organizations. So Redshift offers security capabilities out of the box at no additional cost. So this includes things like compliance certifications, ability to run Redshift in your own VPC, granular row-level, column-level controls, and a new feature we launched this week, dynamic data masking, with which you can protect sensitive data. So all these capabilities, they are available out of the box at no extra cost. And we understand that a lot of times customers, it's a hard thing, it's a challenging thing to actually take a first step with data warehouse migration. So we want to make that simple with a number of tools. For example, the database migration service to move the data from on-prem to cloud. We have schema detection, the SCT tool, with which you can map an existing on-prem data warehouse database to Redshift, accounting for any syntax and semantic differences. And we also have a comprehensive partner ecosystem that can help accelerate the migrations. We have a number of customers that have migrated from on-premises systems. This is one example, NTT Docomo. They are the largest mobile services provider in Japan. They have 79 million customers, and they moved from an on-prem system to Redshift, and they were to see 10x performance improvement at a fraction of cost. And with the managed storage in Amazon Redshift, they're able to scale to petabytes of data and make the analytics available throughout the organization. And we have many other customers. This is one of the most common use cases, which is their cloud journey starts with typically data warehouse modernization strategy. Scaling analytics in the organization also means making the data available to all users, including the users that don't have data warehouse management experience, and also to all the workloads, however dynamic and variable the workloads are. So to deal with these challenges, we have introduced Redshift Serverless. It was announced as a preview last year reInvent, and we have delivered the generally available capability in July this year. The idea is with serverless, you don't have to deal with managing clusters. Redshift automatically provisions the compute, scales the compute based on your workload demands to maintain performance. It takes care of things like patching, version upgrades, backups, recoveries, so that you can just focus on getting insights from your data. And a very important feature of Redshift Serverless is you just pay for what you use. So you have a sporadic workload, for example, that runs for 10 minutes within a 1 hour. You're just paying for that 10 minutes of usage of the capacity. So this is a very important consideration to determine, okay, does this really make sense to me, or should I go for a provisioned workload? provisioned Redshift. We have a number of customers, thousands of customers using serverless every month. Roche is one of the largest pharmaceutical companies, and they benefit from the simplification of serverless. So they are able to onboard new analytics use cases very, very easily without friction. And they also benefit from reduced operational burden and optimized costs with serverless. After the self-service analytics, with AWS and Redshift, one of the benefits you get is you have flexibility on your data management. You can take a data warehouse-centric approach where you keep all the data in Redshift. Redshift has managed storage, which is backed by S3, and S3 is our storage pricing is pretty much same as S3, so you can take a complete data warehouse-oriented approach, or you can take a hybrid approach, which is keep some data in open formats, some data in Redshift, and you can do the analytics appropriately. So Redshift supports both these types of use cases. With Redshift, you can directly query the data in open formats in the data lake with high performance, and also join it with the data in your data warehouse. At reInvent, we added this reInvent. We introduced a brand new capability where you can continue to do ad hoc queries on the data lake, but if you want to ingest data from the data lake, you are able to do it very easily without any pipelines. This is into our zero ETL vision, where data is automatically loaded into Redshift once you set this up. And Redshift also deeply integrates with AWS Glue Catalog and Lake Formation so that you have centralized governance and security. We have a number of customers that take hybrid approach for managing data. NASDAQ is a multinational financial services company. They operate US stock exchange. So they have taken a lakehouse approach in which they collect the data from all the internally operated exchanges and store it in S3. And their teams, such as research teams, surveillance teams, they directly query S3 in place and improve the time to insights. A modern data warehouse also should open up new use cases, such as machine learning, data processing, and more. Redshift offers machine learning capabilities in the database. So Redshift integrates with Amazon SageMaker to provide these capabilities. So with this, you are able to use SQL to create, train, and deploy models, everything using SQL without having to learn any new skill sets. And another nice feature with the machine learning is you can bring your own model. So if you have models that are trained outside Redshift, in SageMaker, for example, you can bring the models into Redshift, and you can do in-database inference. A new capability, so just continuing on the advanced analytics on data warehouse, in addition to machine learning, we just announced the capability to integrate Redshift with Apache Spark. So the idea is simplifying and speeding up Apache Spark applications on top of the data in the data warehouse. So with this integration, you are able to very easily get started with a packaged and certified integration from Amazon EMR or AWS Glue, and you can start building Spark applications and using the Spark's native programming model. So data frames and Spark SQL, and operate directly on top of the Redshift data. So I think the key thing to think about is modern data warehousing is not just limited to the traditional or the standard business intelligence workloads, but more workloads like machine learning and Spark. All these are capable workloads that you want to be able to run on the data warehouse directly. We have a lot of customers using machine learning capabilities in production. Jobcase is one example. This is a technology and AI company, and they run a job marketplace. So they have a lot of big data sets, including things like job seeker information, job interaction data. They store all of that in Redshift, and they have recommendation engines that apply machine learning models on these big data sets. So they have a familiar problem, which is their machine learning models and data, they are not co-located. So what they used to do is take the data out of Redshift, run a batch inference, and bring the data back into Redshift. With the in-database machine learning capabilities of Redshift, they are able to directly do millions, billions of predictions, in fact, directly on the data warehouse data, and not having to move the data out of Redshift. As customers become more and more data-driven and start to kind of see data as a competitive advantage, we hear from customers that they want near real-time analytics. So near real-time analytics are very interesting because customers want to understand their business drivers, grow sales, reduce costs, improve customer experiences. There's so many use cases for real-time analytics. So from Redshift point of view, we are deeply integrating with the rest of AWS ecosystem to make real-time analytics on top of the data warehouse. So at the reInvent this week, we have made generally available streaming ingestion capability. So with this, you are able to ingest high volumes of streaming data into Redshift and make it available for analytics within seconds. And this is a very, very simple integration. You don't have to build any pipelines. You don't have to deal with any complexity of the ETL pipelines that you need to build. You just use SQL. So you simply create a materialized view that points to a Kinesis stream or a Kafka topic, and that's it. The data shows up in the materialized view, and as new data lands on the Kafka stream or Kinesis streams, the materialized view is automatically refreshed with new data. So a very, very simple and straightforward integration where you would use just SQL. And this capability, as I mentioned, is available for Amazon Kinesis as well as for managed service for Apache Kafka, Amazon MSK. We have streaming ingestion for a few months in preview. Joyme is one of our customers. They are using streaming ingestion to do their risk control reporting on user financial data. So previously, they used to do hourly reporting. And now with streaming ingestion, they are able to do near real-time reporting, improving their business efficiency. In addition to streaming analytics, we are also doing deep integrations with our operational databases to enable analytics directly on top of transactional data. For example, a couple of years back, Redshift has introduced federated query capability with which you can directly query Aurora and RDS, MySQL, and PostgreSQL databases and directly from Redshift and join it with the data in the data warehouse. So federated query is very useful for situations like ad hoc queries, data exploration. You're just trying to understand what data is there. And then you figure out, OK, this is the specific data that I want to bring it into Redshift. Now at reInvent, we are very excited about a launch of a new capability, which is zero ETL integration between Amazon Aurora and Amazon Redshift. So the idea is to enable near real-time analytics on petabytes of transactional data that you can combine from multiple Aurora databases into one Redshift. And with this, data is continuously replicated from Aurora and made available in Redshift within seconds after the data is written to Amazon Aurora. So this is a very, very powerful integration with which, as you can see, we are moving towards real-time analytics, streaming support, transactional data. And the idea is the decision-making systems in organizations, customers who just wanted real-time for a variety of use cases. So now we have seen how do you get the data across the data lake, streams, operational databases. Now we want to make it available in a consistent fashion throughout the organization, which is where data sharing comes into the mix. With Redshift data sharing, you can share live and transactionally consistent data across Redshift data warehouses. And these data warehouses could be provisioned or serverless. These could be in the same account, different accounts, or even across regions. So cross-region sharing is a very popular use case with data sharing. And the idea is, again, you're not making any data copies or data movement. You collect the data from your source systems and make it available in the organization. So data sharing is enabling our customers to form very flexible, multi-cluster, what we refer as data mesh architectures. And at reInvent this week, today morning, in the data keynote, we announced an integration of data sharing with AWS Lake Formation, with which, in addition to being able to share data directly between the data warehouses, you can actually share as the producer of the data with AWS Lake Formation. And all the consumers would come in, they discover the data from AWS Lake Formation, and they query it. The benefit of this is now you can centrally manage, you can specify the access control, you can govern the data access from lake formation in a central place across all your data sharing consumers. We have a lot of thousands of data sharing customers. Data sharing has been GA for almost a year now. And Fannie Mae is one of our largest data sharing customers. They have a decentralized approach for data warehouse management with tens of Redshift clusters. And previously, they had to unload data from one Redshift cluster to another. With data sharing, they are able to seamlessly collaborate across all their application teams. And they also share data between the pre-prod research and the production environments seamlessly without any data copies. Redshift also integrates with Amazon AWS Data Exchange, ADX, for third-party collaboration. As I mentioned, the idea is within your data warehouse, you want to be able to subscribe, you want to be able to discover, subscribe, and consume third-party data sets, and you want to join it with the data in your data warehouse. And in addition, a very common growing use case is you want to make the data that is in your data warehouse available to the rest of your business ecosystem. So both inbound as well as the outbound data sharing outside your organization. And data exchange integration is built on data sharing. So this is live data access, no ETLs, no copies, no data movement is needed. And data exchange takes care of all the subscriptions, payments, basically the licensing aspects of the third-party collaboration. So now that you have some idea on all the key use cases enabled, I'd like to ask Shruti to show a quick demo illustrating some of these use cases. Thank you.
Hey, folks, can you hear me? I'm so sorry for my voice. Let me just apologize for that. I don't know what I did, but I can't speak. So I'm just let me know if you can't, and then I'll try to project more. But with that, Nirja, thank you so much. You know, I think Nirja spoke a lot about, you know, what all we can do. So let's take this into action, right? So I put in a quick demo together, and we're taking into account like a lot of things that we saw. So over here, what we have is a hospital chain is what we are taking in as a customer of ours, right? And one of the major problems that they are experiencing is, you know, all of their data is siloed, right? Like a lot of data coming in from a lot of different places. And what they have to do in the past is build expensive ETL pipelines to be able to get all of that data onto their EDW platform, right? Like their enterprise data warehouse platform. So how do we avoid that, right? So with Redshift, we'll see that there are ways in which we can get automated data in from something like Amazon EMR or even Kinesis data stream directly into Redshift without building any expensive ETL pipelines. Or two, actually query data which is sitting not in the EDW but somewhere outside, in this case, Amazon Aurora or in AWS Data Exchange, and then query it directly from there. Then we'll take a look at, you know, hey, now we put all of this data together. Some is with us, some is not with us. You know, can we actually join all of that together? And the answer is yes. We'll quickly look at like one simple query on how that looks like. Then we'll take a quick look at, you know, can we take a subset of that data and actually share it with others within the organization? In this case, can I take a subset of the data and share it with maybe my data scientist who can build Redshift ML algorithms on top of it and you know, create mechanisms on top. And lastly, you know, how do we take that data and make it available to our end users? So let's quickly jump onto the demo. Okay, so first, we have multiple raw data files which have like average procedure times and pricing of different things sitting in S3 data lake. So using EMR serverless, we're going to have our data engineers, you know, try to merge all of that, right? So serverless, EMR serverless, you go and create a job, and the job is actually running a PySpark script at the back end. You look at the PySpark script, and what the script is doing is, one, it's massaging the data, you know, merging multiple data sets into a single data set so that it becomes easy to load into Redshift. But then second, you're actually specifying the Redshift URL, IAM role, the bucket from which we are loading, directly within that script itself. And it makes it very easy to directly not just transform the data, but create a table and load the data from EMR into Redshift directly. Now, we go to Redshift, and what we are running a small query to see, hey, is the data in properly or not? And what we see is, yes, it is. We see the provider IDs. We see the different things. Now, moving on to Amazon Aurora. Over here, the data is sitting in Amazon Aurora. The only thing that we have to do is create an external schema pointing to the Amazon Aurora cluster. So you can see the PostgreSQL is connected now as an external schema. And what we do is we build a small federated query. So federated query means we are running a query against Aurora. Again, a small query to see, can we get the data in? And as you see, give it a second to run. As you see, we are able to get all the hospital care information. So we see the hospital, the different procedures that they're running, and the average score associated with it. Next, let's take a look at data exchange. One of the common challenges that we have is, hey, are there other third-party data sources that are available? So using AWS Data Exchange, we can actually search for any third-party data sources. In this case, it's a census data. We look for it, hey, let me look and ensure. So there are two types of data sets that are available, some which are available on S3, some which are available on Redshift Data Share. We validate, hey, is this available on Redshift Data Share or not? Let's take a look. The population data is available on a Redshift Data Share. Since I already subscribed to it, let's go to the subscription. Let's click on it again. And under an actual data set, there could be multiple data files that would be available for you. So what we are doing is we're going in and selecting the actual data file that we want to build the database from. We go in, select it. This takes us to the Redshift console. And what we have to do is just connect it to the database. In this case, I've already done it. So it becomes available as an accessible data share within Redshift itself. So we are at Redshift, go, and it shows that, hey, the US Census population data share is available for me. The only thing that I need to do is validate that, hey, is the external schema available for ADX? Yes, it is. I run a small query to see, hey, do I have all of the population data populating here or not? I do. I see the GeoID, I see the cities, I see the zip code, and I see all the population information directly accessible with the Redshift. And last but not the least, I want to know which are my patients who are checking in, checking out from the hospital. So this data is actually coming in from the Kinesis data stream. So there are multiple streams that are created over here. And as Neerja mentioned, very simple. I create an external schema. That's it, referencing the Kinesis data. And then second thing that I have to do is I build a materialized view connecting to that Kinesis data stream. And what I do is utilizing auto refresh, whenever new data is coming in through these streams, it becomes automatically available within Redshift. And so let's quickly see, are we actually getting this information or not from Kinesis data stream? Again, a very short query to look at the check-in, check-out information. And what do you see? I have all the patients. I see which hospital did they go to. And for every patient that went to the hospital, what is the care that they took? And did they check in? Did they check out? Now, let's take a look at putting all of this data together, right? So we have data that's coming in from our ADX. We have data that's coming in from our streams. We have data that's coming in from our Aurora. And last but not the least, we have data that's actually sitting in within our Redshift cluster that we pulled from EMR. So I'm joining data across all of these 4 data sets. And what do we have? I am able to see, give it a second, it'll take a second to run. But what we see over here is I am able to pull in all the information together and have one view about what were my existing capacity, based on that, what is my current capacity, what were the events that happened, where is it that we are servicing, and based on the county that we are servicing, what is the population of them, and last but not the least, what is the hospital, etc. So again, we were able to put all of that data together. Now, data sharing. What we want to do is, we want to take subset of that data, right, and make it accessible to other Redshift serverless instance. So we created a data share called Hospital Share DB. What we'll do next is we'll alter that data share to call out, hey, which is the schema that we want this data share to read from, and within that schema, which is the table that we want it to read from. Once it's done, if you go to the data share console, you can actually see that it's available, right? I can go to the consumer cluster and I can find a namespace. A namespace is something which is unique for this data sharing account. This helps us almost do a handshake, right? Like, so what we are doing over here is I'm saying, hey, grant usage to the data share that I created to the consumer cluster, right? Let's see, is that data share now available to me or not? I click on show data share on consumer. Yes, it is. What I'm doing is I'm looking at within that data share, what are the data objects that are available for me? And I can see within the, the hospital share DB, the hospital effectiveness DB, the table itself is available for me. Now, what I'll do is I actually have to do a handshake, right? So you grant access from one side, I have to grant usage on other side as well. So I go in, and I'm actually grabbing the, the namespace from the producer cluster, and I'm creating a database for it called pricing database, right, from the hospital share DB. And when you go to the consumer cluster, you'll see that the pricing database is actually available for us. Very easy. So now, what we did is this pricing data set, who did we created this for? We created this for our ML scientists, right? So our ML scientists want to build predictive pricing of different procedures on top. What do they have to do? The first thing that they need to do is they need to create a table for, one is training the data and validation the data. So what we do is we take subset of the data that we shared and we create a table for prediction, right? Like for training it. Next, we build a create model called procedure price prediction, and utilize those training data and the validation data for this model creation. It takes a couple of hours to run the model based on how big of data it is and what type of model that you're trying to create. But what we can do is we can run the show model query to know whether this model is ready or not. And as you can see, what that means is I am ready to infer data, do data inference on top of it, right? And this is where the Redshift magic happens, right? Everywhere else, other ML platforms, you pay for both building the model as well as inference. Redshift, you only pay for building the model. Inference is free. So we built a small query to run, hey, do I actually get the predict? What do you see? We have the payment measure name, the payment ID, and the predicted amounts for different payments. Finally, let's make this data available to our end users, our patients. Our patients want to know which are the hospitals that are available for them, what are the average wait times for it, how much do I have to pay for like an estimated, a condition, a health condition. So select a state, select a county, and then we see that there are 2 hospitals available over here. Oh, look at that, the automated data masking in action. I did not want you guys to see the name. I did not have to do anything. I could like just consider it in Redshift, select it, and I could see, oh, the wait times is for the second hospital is low. That's it. I'll go to the second hospital. And then second thing is, as you can see, once I select the condition, I'm able to get a range of what is the range, estimated range that I may pay for a condition. So what did we see finally? One, we were able to pull in data from multiple different type of data sets to avoid the data silo challenge that happens. 2, we were able to make that data readily available within a cluster so that multiple personas can actually take advantage of the data and utilize it the way that they want it for their business use case. And last but not the least, make it available for our end users readily. With that, I would like to call Shyam, who is the director at J&J, to talk about how they were able to take all of this and put it to action. Shyam.
All right. Thank you, Shruti. And hello, everybody. Good afternoon. And I hope that everybody is enjoying the sessions here at the conference and learning new technology and use cases and then features. Right. My name is Shyam Mahapatra. I'm the director of Data and Insight product group at North America Johnson Commercial Pharmaceutical Business. And Johnson is our pharmaceutical division of Johnson & Johnson. Johnson & Johnson has led the had led the reimagining all the health and services across the world, and then helping patients, helping our doctors, and then also helping our nurses over 130 years. So Janssen is the pharmaceutical division of the Johnson & Johnson. At Janssen Commercial, we help patients, patients with complex medical and challenging medical issues across different therapeutic areas. Today, I'll go over in the agenda, I'll go over our journey of data warehouse modernization effort, focusing on challenges, the voice of the customer, our journey at Janssen Commercial, the business benefits and the data architecture that we had, and the learnings and the next steps that we have planned for. So let me start by providing a brief overview and introduction. So my group is the Data Insight Product Group under the North America Janssen Commercial Business Technology. Our vision is to save the future of healthcare through a diverse team by unlocking the power of data through an insight-driven organization for the purpose of improving efficiency, generating value by empowering data users to deliver a better customer experience. Our business data users are not limited to sales and marketing, data scientists, contracting teams, medical teams, market research teams, and then evidence generation, and many more. Some of the key opportunities that we see as the growth in business happens, the data is growing. There is a need for like a data sharing across the organization. New channels are emerging, and looking at like there are new data users in the organization, and new applications are being developed, and then there is a data getting generated in those applications. There is a huge need for the sales service in the organization. Also, like with that, there is a need for the organization to have a faster time to insight, and also look to deliver faster time to data. And also like there is an ongoing pressure of like reducing the cost to deliver those. So when I was coming here to my journey, like to attend the conference, I was thinking, so I generated so much data, right? Going from taking a Uber, paying the toll in the toll roads, taking the airport, airlines, ticketing system, going to restaurants here, or traveling across stations. All of them generates data. We are generating data right now. And that's the data that we are generating. And there is a humongous amount of data which is like untapped as well. And with data comes challenges, and then the challenges will not go away as the data grows. The explosion of the data happens. We need to address that, and then also look at innovative ways and optimize those. There is increased cost to deliver capabilities. So in the organization, as the data grows, the cost of data, cost of storage, cost of compute, as well as delivering insight also grows, and the support cost also increases. The data ecosystem gets more complex over looking at like more data silos across the organization. Scalability has been an issue with legacy tools and technologies. When we look at some of the workloads, at some points, like it impacts to deliver the right data at the right time to our customer, because it is impacting some of the workloads as well. Data sharing, as Neeraja talked about, also some of the features that are coming, and then over the organization, there has been a need to share the data with multiple data silos. With that also, like there is an operational overhead on managing the cluster, managing the pipelines, as you saw there's a zero ETL pipelines coming in, and then it was launched today morning, and there is also talked about that. So how do you avoid those operational overheads? There's also a growing need for self-service. The business doesn't want IT. They want to have a self-service and then do themselves. So how do you enable those user groups? With the data growth, there's new users coming in. There's new applications are being created and also generating more data. With all this, like there is always a demand from the organization and business to deliver faster time to deliver those data and insights. So our journey started 2014, and before I go through our journey, I'm not sure if some of you have seen the video. So Redshift has had a commercial, 2 minutes video of capabilities. So there was a character who was sitting in the beach, and where the data warehouse was running automatically. So I went to my manager and I said, you know what, you could be you here sitting in the beach, and then the data warehouse runs automatically, and then you'll be enjoying. So our journey started at 2014. With 2015, we moved some of our on-premise RDMS to Redshift as a foundation to our data ecosystems. Over the years, like we have optimized, used some of the features that came in with the Spectrum to reduce and optimize cost. And also like moved a lot of our legacy data warehouses into the Redshift data warehouse. So last year we started to migrate our Redshift DC and DS instances to RA3, and then also like started to leverage or use some of the features that were available on the data sharing. And as we speak now, we are looking at serverless and other features that are available for us to use. So some of the key business benefits that we see, like when we started our journey, one of the things I was asking, when we need more data to store, we are stuck with the compute and storage. So even though our workloads were not compute intensive, we have to use the compute. So with the benefit of RA3, where the compute and storage separation happened, it supported the data growth, the business growth, as well as look at like we want to be sustainable, right, in the environment. So it reduces the carbon footprint, because the compute needs are not there, and it lowers the computes wherever it's not needed. Data sharing, it enabled better user experience for us. Also, like reduce the data duplication across the organization. Also, it enabled data interoperability and innovation. It did drive innovation on the organization. Before the sharing features were available, we need to do a cut of the data and then ship it to the other cluster or other parts of the organization. So with the data sharing, it helped to streamline that. There are better cluster management with query capabilities, concurrency, and other aspects that help to reduce our administration and also operational overheads. Data growth, as business grows, the data growth grows with it, and then we had 20 times growth in our data. And with RA3 and Redshift, it was able to sustain those growth and demand. And also, as you look at, there are new use cases coming with personalized medicine coming in, additional data coming in with omnichannel and personalized patient experience as well. So with that also, like there's new applications and user base coming in. that needed like the self-service, and also it also helps to democratize the data across the organization. Finally, like this is important where like we need to look at the cost and effort, right? So it also helped to reduce 30% reduction in our like operation cost, and then 50% faster time to delivery to our business users. As there is a new user groups coming in, they needed self-service with the data citizen scientists, citizen data users, as well as the analytics users. And then also looking at some of the AI and ML capabilities and real-time data and data APIs, the self-service, it helped the organization on the self-service side of it. Scaling. Also, it optimized our production workload, supported new dynamic workloads that came with the AI and ML side of it. So this was our prior architecture. So from the left to the right, the data producer to the data consumers. There are like multiple ETL tool pipelines, PL/SQLs. The data was copied in multiple RDMS systems. So it was hard to manage, and then the time to market was slow for adding new data assets. Like back then, like when some of you might be already aware of it, or at that time when I needed like more like disk space, you have to create a request. It takes 3 months to 6 months to do it. But now click of a button, you can increase the size. So from here, we went to a newer architecture. When you look at the left-hand side, we are able to add in more data assets, more channels as it emerged, EMR, EHR, and others. Data comes to S3, and then a lot of our processing happen on EKS, on Spark-based processes. And then finally, it goes to Redshift. We also use Amazon Data Exchange to improve time to delivery. It has a direct connect to Redshift, and once the data provider provides the data, it automatically shows up in Redshift, and you start querying and building your applications and visualization and other things. And then with the Amazon Data Exchange or AWS Data Exchange, the architecture can scale easily and then generate faster insights to the end user as well. With recent modernization effort to our Redshift RA3, we moved all our dense storage and dense compute migrated to RA3, like 100 plus terabytes of data migrated, and then some of the bigger cluster took less than 2 hours of time to move migrate it. We didn't have any downtime. There was zero net cost increase, and RA3 backward compatibility also helped, enabled seamless integration or transition to for our users and applications as well. AWS team was there to help, and then whenever there were some of the challenges, issues encountered, they were able to help us during the journey. Some of the key recent learnings, when you start the journey of migration, look at the right sizing, so from DS and DC instances to RA3. Start with small cluster and non-prod so that you test it out. You can start to plan to use some of the new features that are enabled with advanced WLM, looking at like data sharing capabilities or other integration with ADX and other capabilities that are out there. Not everything went smooth. There were some hiccups along the way. So encryption for bigger cluster was taking some more time, and that's a need for when you want to enable cross-cluster data sharing. And the AWS team was there to help us solve that pretty quickly. Also, like when we tried the elastic resizing, there was a bug with the system, and then the AWS team timely provided to mitigate those challenges, issues. So what next for us? We are planning to expand the serverless to run and then scale some of the analytics use cases. We want to expand our use of ADX to enable more self-service for organization for faster data access. Also, we wanted to scale the data sharing capabilities across the organization. We have been using, and then we want to expand furthermore. So with that, thank you everybody for listening. Thank you.
Thank you, Shyam. Yeah, so I think we are at the end of our session. You can get started with Redshift today. You can start with Redshift serverless, very quickly spin up if you are new to Redshift or if you have new use cases that you want to try out. You can get started. You can visit Redshift page for more information, whether you are new to Redshift or you are using Redshift, there is information for you. And we also have a migration program if you are considering, so there is a little bit more information on that as well. So with that, thanks everyone, and we can take some questions.